Hello, this is Miss Moore, and today during chemistry we're going to continue our discussion on stoichiometry. Today we'll be talking about the limiting reagent. Today's essential question: how is the limiting reactant or reagent in a reaction determined? For today's lecture, you will need to have handy a calculator and both your handouts. The limiting reagent. We'll start with a quick overview on what a limiting reagent is and why would we even want to talk about it. All right, so all of the reactions and calculations thus far have described what we call an ideal situation. Okay, and the ideal situation is that we have an unlimited supply or amount of both of the reactants, all of the reactants. Okay. However, in a chemical reaction, an insufficient, meaning not enough, quantity of any of the reactant will limit the amount of product that forms. And that's actually more real life. In real life, we don't usually have an unlimited supply of all of our reactants. Okay, so again, if we have a limited quantity of any of the reactants, one or more of the reactants, we're going to limit the amount of product that can be formed. So, what is a limiting reagent or limiting reactant? Okay, mean the same thing. All right, so the limiting reagent is the reactant that is completely used up during a reaction. Okay, so at the end of the reaction, no more of that particular reactant, the reactant that's the limiting reagent. Okay, a limiting reagent limits the amount of the other reactants that can participate in the reaction. Why is that? Well, let's say we had two reactants, one of which is the limiting reagent. Once it's been completely used up, the reaction can't go any further, even if there's more of the other reactants left over. Okay, so a limiting reagent limits the amount of other reactants that can participate in the reaction. Limiting reagents also limit the amount of product that can be formed. Because if you have a limited amount of reactant, you can only make so much product. And the reaction stops when the limiting reagent is used up. And then we have something that's the opposite of a limited reagent, and that is excess reagent. An excess reagent is not used up during the reaction. All right, so we now know what a limiting reagent or limiting reactant is. How do we figure out which of the reactants in a particular reaction are the limiting? Okay. So the first thing you're going to do is you're going to use our three-step stoichiometry method to determine the mass of product that can be produced from all, if you would like, of the reactants. Okay, so you need to go to the mass of the product that can be produced from each of the reactants. You only need to do the calculations with one of the products. It doesn't matter which one, but you only need to do the calculations with one of the products. And while it doesn't matter which product, make sure you use the same product for both calculations, for all calculations for each reactant. So how do you know which one's the limiting reagent or reactant? Well, the reactant that produces the least product is the one that's limiting. And the amount of product formed from the limiting reagent is the maximum amount of product that can be formed. All right, so we just went through a whole bunch of definitions there. The next step is to try this. All right, so for our practice, we have a 2-gram sample of ammonia is mixed with 4 grams of oxygen, which is the limiting reactant. You'll notice that you were given two givens, right? 2.00 grams of ammonia and 4 grams of oxygen. Okay, so we have to do two mass-to-mass conversions to figure out which is the limiting reagent. So let's start with our given being ammonia. So our mass known is going to be 2.00 grams NH3. And our unknown, we get to pick. I'm going to go ahead and pick NO. It doesn't really matter. We have to pick one of the products as your unknown. So I'm going to say blank grams NO. That's who I'm going to use. We have to go through blank mole of known. And we have to go through blank mole of unknown. So again, I'm starting with one of my givens, in this case the ammonia, and I need to calculate the mass of one of the two products. It doesn't really matter which one you pick, you'll get the same answer. All right, so our map tells us this is going to be a 4-grid problem. So we'll start with bringing our known and putting it in the grid. So that's 2.00 grams ammonia, or NH3, over 1. Okay, and then we need to convert from mass known to mole known. So the equality that has those terms in it would be 1 mole of the known, or 1 mole NH3, equals the molar mass of NH3, which we're going to add up the molar mass of 1 nitrogen and 3 hydrogen, giving us a mass of 17.04 grams NH3. If we look at sig figs, 14.01 for nitrogen, that's 4 sig figs. Hydrogen has 1.01, 3 sig figs. So our mass will be 17.0 grams NH3. We'll put that on the bottom. And on the top, we'll go 1 mole NH3. Okay, and our mistake blockers, does grams NH3 cross out grams NH3? It does. We're at mole NH3, which is where we expected it to be. So we haven't made a wrong turn yet. So far, so good. Okay, so we are at mole known, or mole NH3. And how do we get from mole NH3, or mole known, to mole unknown? This is where we use the mole-mole ratio from the balanced equation. So our known is NH3, and our unknown, we decided, would be NO. Okay, so we will put on the bottom, so we can cross out 4 mole NH3, and on the top we will have 4 mole NO. Let's check our mistake blockers. Mole NH3 crosses out mole NH3. We are now at mole NO, which is where we're expecting to be at the moment, so we're still on the right track. Okay, so from mole unknown, we need to go to mass unknown. The equality that has those terms in it, mole unknown and mass unknown, is 1 mole of the unknown, which in this case is NO, equals the molar mass of the unknown. So we're going to take the mass of a nitrogen and plus the mass of an oxygen, and that gives us 30.01 grams NO. And nitrogen and oxygen both have 4 sig figs, so our answer is going to have 4 sig figs. We're going to put 1 mole NO on the bottom for crossing out, and on the top we'll go 30.01 mole NO. All right, let me change this from mole NO to grams NO, and let's make sure these cross out, and they do, and we're at grams NO, which is where we expected to be. And we're at the end of the problem. All we've left to do now is plug the stuff into our calculator. So when I multiplied across the top, I came up with 240.08 grams NO. Please be double checking me. And when I multiply across the bottom, I came up with 68.0. And then we divide, giving us an answer of 3.53 0.0588 and so forth grams NO. If we go back and look at sig figs, we have 3 sig figs, 3 sig figs, those don't count, and 4 sig figs. So it looks like our answer needs to have 3 sig figs. So we can make 3.53 grams of NO using 2.00 grams of NH3. Alrighty, we need to do the problem again, this time using 4 grams of oxygen, and see how much NO we can make with 4 grams of oxygen. Remember, we're trying to figure out which reactant makes the least amount of product, and we picked NO as our product of choice. Alright, so our known this time is going to be 4 grams of oxygen. So we're going to have 4.00 grams of oxygen as our known, and our unknown will again be blank grams of NO. We also need to figure out, or go through at least, mole unknown, or mole known, and mole unknown. Just like the last problem, this is going to be a 4-column problem. We'll start by writing our known, which is 4 grams O2 over 1. And then to go from mass known to mole known, we're going to use 1 mole of the known, O2, equals the molar mass of the known, which we're going to add up oxygen plus oxygen. And we end up with 32.00 grams O2. And we'll put the grams on the bottom so we're able to cross out. And on the top we'll go 1 mole O2. All right, let's try our blockers. We're at grams O2 and grams O2. Those cross out. We're now at mole O2, which is where we're expected to be, so we're still going the right direction. We now need to go from mole known to mole unknown. And mole to mole is the mole-mole ratio from the balanced equation. And our known is O2, and our unknown is NO. So we'll put 5 mole O2 on the bottom and 4 mole NO on the top. Let's check that we set things up right. Mole O2 crosses out mole O2. We're now at mole NO, which is where we expect it to be. All right, we are at mole unknown, and we're going to mass unknown. And we already figured out this equality. In the last problem, so we have 1 mole of NO equals the molar mass of NO, which was 30.01 grams of NO. We'll put 1 mole of NO on the bottom and 30.01 grams of NO on the top. We will make sure they cancel out mole NO with mole NO. Now we just need to do the calculations, multiplying across the top, multiply across the bottom. So when I multiplied across the top, I got 480.16 grams NO. Please be double checking me. And when I multiplied across the bottom, I got 160.0. And then we divide, giving us 3.001 grams NO. Sig figs, we have 3 sig figs. That didn't work out well, that's better. 3 sig figs, 4 sig figs, those don't count, 4 sig figs. So we're going to have 3 sig figs. So that means we can make 3.00 grams of NO when we start with 4 grams of O2. All right, so going back to our original question, when we had 2 grams of ammonia, we made 3.53 grams of NO. When we started with 4 grams of oxygen, we made 3.00 grams of NO. Okay, so we made less NO with the 4 grams of oxygen, which means our limiting reagent is the 4 grams of oxygen. Okay, so there you go. That is how you calculate limiting reagent. You just solve for one of the products using the mass of one of the reactants, do the whole problem. Solve again for the same product using the mass of the other reactant, and just see which one made the least. That's the limiting reagent or reactant. Okay. We next need to figure out, how do you determine the amount of excess reagent? Remember, the excess reagent is the reagent or reagents that were not the limiting. Okay, so the extra reactants. Okay, so to determine the amount of excess reactant that did not react, you first need to determine how much did react. So how do you do that? It's right there. Do a mass-mass conversion with the mass of the limiting reagent or reactant as the given, and then your unknown is going to be the mass of the excess reactant. Okay. The answer that you get will be how much of the excess reactant was used. To actually figure out how much was left over, you subtract your answer from the starting mass in your question. Okay, so we're going to use the same example that we used for determining the limiting reactant, and that is a 2-gram sample of ammonia is mixed with 4 grams of oxygen. The question now is, how much excess reactant remains after the reaction is stopped? So let's go back to our previous answer and try to recall which was our limiting reactant. So our limiting reactant was 4 grams of O2. So we're going to use 4 grams of O2 as our known. So our known is 4 grams O2, and our unknown is going to be grams of ammonia. Not 2 grams, but just grams of ammonia. Because if we use 2 grams, then we don't have an X, and what we're trying to do is figure out how much ammonia was actually used with the 4 grams of oxygen. Okay, so we're going to have 4 grams of oxygen is our known, and our unknown is going to be grams of ammonia. We're also going to need to figure out the number of moles of oxygen, or at least drive through, and moles of ammonia. All right, so once again, we have a problem with 4 grids. We'll start with 4 grams O2 over 1. To convert from mass known to mole known, we're going to use 1 mole of the known, which is O2, equals the molar mass of the known, which is 32.00 grams O2. We'll put 32.00 grams O2 on the bottom and 1 mole O2 on the top. See if these cross out. Grams O2 does cross out with grams O2. We're at mole O2, which is where we expect it to be. So far, so good. All right, so from mole known or mole O2, we need to go to mole unknown or mole NH3. This is where we use the mole-mole ratio from the balanced equation, with our known being O2 and our unknown being NH3. We'll put 5 mole O2 on the bottom and 4 mole NH3 on the top. Our mistake blocker looks good. We're at mole NH3, and that's where we expected to be. So we're still on the right track. And now we need to convert from mole unknown or mole NH3 to mass unknown or mass NH3. So we're going to use 1 mole of the unknown, which is NH3, equals the molar mass of the unknown, NH3, which means we're going to add up 1 N and 3 H's, giving us 17.04 grams NH3. However, we only have 3 sig figs because of the hydrogen. So our molar mass of NH3 will be 17.0 grams NH3. All right, we'll put the 1 mole NH3 on the bottom and the 17.0 grams NH3 on the top. They cross out. We're at grams NH3, which is where we expected to be, and that also shows us that we're done with setting up the problem, and all we have left to do is calculate. Okay, and as we do the calculations, please double check me. So when I multiply across the top, I come up with 272 grams NH3. And when I multiply across the bottom, I end up with 160. When I divide, I get 1.7 grams NH3. When we look at sig figs, we have 3 and 4 and 3, so we'll have 3 sig figs. So we'll have 1.70 grams NH3. Okay, so when we used 4 grams of O2, we used up 1.7 grams NH3. That, however, is not our final answer because it wants to know how much excess we had. So if we look back at the original problem, we started with 2 grams of NH3. We used a total of 1.7 grams of NH3. So how much is left over? Well, we'll take how much we started with, and we started with 2.00 grams of NH3. We used 1.70 grams of NH3. If we subtract those, we have an excess of 0.30 grams NH3. And that is our excess. There you go. This was a long one, but that's it for today. Have a good one.